Hello, welcome to Astronautics for Exploits. This is Dr. Ayoshola Ogundele. Mars versus Moon, a tale of potential celestial objects with possibility of becoming future human home in space. The focus points of my presentation are as follows: Mars and Moon, and comparison of Mars and Moon characteristics. About 4.5 billion years ago, the solar system is said to be settled into its current layout, with Mars, the fourth planet from the Sun, and about half of the size of the Earth, formed when gravity pulled swirling gas and dust together. The most unique perspective as a science platform to look back at the Earth, observe the Sun, and feel the vast universe is endearing many space agencies, private companies, and investors into focusing on developing less costly reusable launch vehicles which can transport humans to the moon for living, working, research and development, and mining activities. The moon bears substantial natural resources which could be exploited in the future. Potential lunar resources may encompass processable materials such as volatiles and minerals, along with geologic structures such as lava tables that together might enable lunar habitation. Findings show that Mars promises to be a new frontier in space exploration, and colonizing Mars will be a very significant achievement for humankind. There are various distinguishing factors between Mars and the Moon. On both the Moon and Mars, the risk of radiation and meteor impact is significantly higher than on Earth. The thin atmosphere on Mars provides meaningful protection from some radiation and from small asteroids up to 1 meter in diameter. The lack of atmosphere in the Moon is one of the reasons for shifting of attention and focus to Mars. Although Mars' atmosphere may not be as robust as the Earth's, but is more robust than the Moon's atmosphere. The effects of partial gravity on human Earth remain uncertain, and there is good reason to believe that the closer we can get to Earth's gravity, the better. Research suggests that biological systems will tolerate the relatively stronger partial gravity of Mars better than that of the Moon. Mars and the Moon. Mars, which is also known as the red planet, is the front-runner celestial object in our entire solar system to become a possible new home for humans if terraformed. Mars is the fourth farthest planet from the Sun and one of four mainland terrestrial planets in our solar system. The picture here shows comparison of Mars and Moon distances. Mars is bigger with a diameter of 6,779 kilometers as opposed to the Moon's 3,474.8 kilometers. Mars has the most moons among the normal terrestrial planets, where two Deimos and Phobos are currently orbiting the red planet. The Moon has no object orbiting it, and it is dark gray, while Mars is red in color. Illustration of Mars and Moon is shown in this picture. Mars is probably the most explored planet outside of the Earth, with a multitude of rovers like Sojourner 1997, Opportunity 2004 to 2018, Spirit 2004 to 2010, and Curiosity 2012, Perseverance 2021 that have landed on the Martian soil to explore it. Various companies planning to have astronauts land on the Martian soil, possibly as early as 2029. Mars has a lot of interesting things in its terrain as a potential substitute for Earth in the future. NASA's Parker Solar Probe is shown in this picture. The Moon. The Moon is a natural satellite and a gray celestial being that orbits our Earth. It is also tidally locked to Earth, and this implies that we only see one side of it at any time in our sky. It takes the Moon roughly 27 days to complete an orbit around the Earth, which is thus in an elliptical pattern. The Moon's axial tilt is very straight at 1.5 degrees. As a result of the tidally locked status along with the effect that Earth has on its general rotational pattern, it takes the Moon about 29.5 days to complete a day. Illustration of the Mars and Earth is shown in this picture. Moon's surface is mostly made of rocks, iron, magnesium, just like most of the other moons and terrestrial-based planets in our solar system. Moon is among the bigger moons in our solar system, with a diameter of 3,474 kilometers and a mass of 7.35 times 10 to power 22 kilogram, which places it fifth among all moons in our solar system and will also make it bigger than the dwarf planet Pluto. SpaceWorks' proposed Mars transport is shown in this picture. The similarities between Mars and the Moon are both of them have a autocentral core, both have a rocky terrestrial surface, both are spherical in shape, neither have rings surrounding them, and their core temperatures are relatively the same. The picture here shows illustration of Venus, Earth, Moon, and Mars. Comparison of Mars and Moon characteristics. Some of the comparisons are atmosphere, day-night cycle, temperature, gravity, transit time, and nutrients and resources. The moon's surface is engulfed by the vacuum of space, and it has no appreciable atmosphere. So like Earth and the other terrestrial worlds, Mars does have an atmosphere, certainly more visible than that on Mercury, but when compared to Earth, it is merely 1% of its volume. The picture here shows solar system. Mars and Moon radiation. On both the Moon and Mars, the risk of radiation and meteor impact is significantly higher than on Earth, and the thin atmosphere on Mars provides meaningful protection from some radiation and from small asteroids up to 1 meter in diameter. Illustration of Mars expressed in orbit around the red planet is shown in this picture. The Moon has no radiation protection, and the surface receives heavy bombardment by meteoroids traveling as fast as 47,000 kilometers per hour. These meteoroids, which can cause significant damage to structures, will not survive entry into the Martian atmosphere. Mars' atmosphere provides a valuable resource. Through various processes, Martian atmosphere offers a potential source of breathable air and propellant. The Moon lacks these crucial assets. An artist's interpretation of the event where a single moon orbiting Mars was struck and split into two moons, Phobos and Deimos, is shown in this picture. Day-night cycle is another comparison. A day on the Moon lasts for 28 Earth days. Humans on both the Moon and Mars will spend much of their time inside pressurized habitations. The drastic transition to the day-night cycle of the Moon will introduce a further complication to the management of human health. Sleep is essential to our physical and psychological well-being, and light exposure modulates our sleep-wake cycle via our circadian rhythms. NASA Gateway is shown in this picture. A day on Mars is roughly the same as one day on Earth at about 24 hours and 37 minutes. 1 year on Mars is about 687 Earth days. Mars' axial tilt is also very similar to that of Earth, where it is positioned around 25 degrees to the right. Illustration of Earth and Moon is shown in this picture. Temperature is another distinguishing factor. As a result of the drastic day-night cycle, the Moon experiences far greater temperature fluctuations than Mars. The Moon alternates between 127 degrees Celsius in sunlight and minus 173 degrees Celsius in darkness. This places further restrictions on the design of lunar habitats and infrastructure. Mars is on the colder side, with a temperature of around minus 65 degrees Celsius on average. On the contrary, its core is significantly hotter at 1,350 degrees Celsius. Martian season is shown in this picture. Gravity is another distinguishing factor. The Moon has very little gravity, although the effects of partial gravity on human Earth remain uncertain. There is good reason to believe that the closer we can get to Earth's gravity, the better. Research suggests that biological systems will tolerate the relatively stronger partial gravity of Mars better than that of the Moon. Moon to Mars concept is shown in this picture. Transition to partial gravity will be a psychological challenge on human beings. With more than twice the gravity of the Moon, we can expect that the shift to Mars gravity will be comparatively easier. Minus of the Moon is shown in this picture. Transit time is another distinguishing factor. Proximity of the moon to the Earth attracted more humans' missions to the moon. The shorter journey results in less radiation exposure in transit, far less communication delay, and opens the door for rapid rescue from danger. The far distance to Mars adds mission complexity and risk. Mars exploration rover is shown in this picture. Mars and Moon resources. Research findings show that Mars has more resources than the Moon. In contrast to the Moon, Mars is rich in carbon, nitrogen, hydrogen, and oxygen, all in biologically readily accessible forms, such as carbon dioxide, gas, nitrogen gas, and water ice and permafrost. Moon, on the other way around, has the resources such as carbon, nitrogen, and hydrogen, and they are only present on the Moon in parts per million quantities, much like gold in seawater. This picture shows China's Chutu moon rover, which is currently exploring the lunar surface. Proximity of the moon to the Earth attracted more human missions to the moon. The concept of future human space activities on lunar surface is shown in this picture. The table here compares Earth, Mars, and lunar characteristics, such as the mass, comparative mass, diameter, escape velocity, average distance, rotation speed, revolution speed, mean surface temperature, and atmospheric component and atmospheric pressure. For more information, contact Astronautic for exploits. You've been watching and listening to Mars vs. Moon, a tale of potential celestial objects with possibility of becoming future human home in space, presented by Dr. Anyashola Ogundele, with the focus points Mars and Moon and comparison of Mars and Moon characteristics. Thank you.